In this Algebra 1 video, Chapter 2, Lesson 7, we're going to talk about percent of change. As a heads up, this topic should sound very familiar and if you need a review and deeper review and coverage of some of these topics, look at our Chapter 6 videos from last school year, or your Chapter 6 notes or tests, stuff like that, help you refresh yourself. Anyways, let's do this. Our objective is, as the student, I can find the percent of change and I can solve problems with discounts and taxes, all because I will utilize the basics of percents. And we're just going to take it one step further. We're not in algebra, we're not really going to focus on what is 20% of 80. We're not really going to focus on 5 is 12% of what number. Those are the type of questions we're going to do. We're primarily going to focus on problem-solving types of questions. But yes, we're going to start with some basic skills first and then work our ways towards that. But for a view on percentages in general, check out some of the stuff from Chapter 6. Percent of change, that's the first thing we're going to talk about. Because you'll notice there are three things we're going to talk about. We're going to talk about percent of change, and we're going to talk about discounts and taxes. So percent of change, in general, it is the ratio of the amount of change compared to the original starting amount. That's essentially what the definition of percent of change is. But specifically, how to find it, we're going to use this formula. This should look very familiar from last school year. You take the new number, or the newer number, or the number that came later, especially if we're talking chronological order, and then you do new number minus original number, or the older number. So the newer number minus the older number, take that answer and you divide it by the older number, or the original number. And when you do that, you will get a decimal answer. Usually it'll be less than 1, but sometimes it'll be worth more than 1 if your question is more than 100%. Anyways, if you do it in this order specifically, new minus original, if you end up with a positive answer, then that means you have a percent of increase question. But if you end up with a negative answer, you're going to have a percentage of decrease question. Meaning if it was a negative number, that means you have the new minus original. If that equals a negative, that means the original must have been bigger. So if the original was bigger than the newer one, that means it got smaller. So yeah. But in general, if you're worried you did these backwards, or you're not really sure if you can trust the positive or negative, what I want you to focus on is what we said last year. Use your common sense. Meaning, if you know that the newer number is bigger than the older number, make sure you say increase of however many percent. And so if you have to, ignore the sign if you accidentally did it backwards. Use your common sense. It doesn't have to be magic. If it got bigger, it's an increase. If it got smaller, it's a decrease. Okay, so I'm going to help you with 2 examples, and you're going to do 2 examples. But I want to point out, in each of them, remember, we're going to use this general equation, formula I guess you could call it, new number, or newer number minus the original, divided by the original. Now, assume our instructions said to round to the nearest whole number, or the nearest whole percentage. Assume that's what our instructions said. So we're going to take each of our final answers, and we're going to do that. So the first thing you want to do is make sure you can identify which is the new number, which is the original. Now, in the first few examples you'll have, including on your practice assignments, they're going to make it really obvious. They're literally going to call them new and original. However, if you're doing a word problem or you're doing a problem like that, make sure you're reading into it and you're paying attention to which one of the numbers came later, which one is the newest or the new current number. So whichever one is older or came first, that would be the original. So in our example, the new will be, I'll do the new in red and I'll do the original in green. Alright, so just plug those into that formula. Okay, so plug everything in where it goes, and then now just solve, meaning subtract the top first. 10 minus 25, well, that's negative 15. So you're going to do negative 15 divided by 25. And if you do that, you'll end up with negative 0.6. So now that's your decimal answer, I agree, but we're looking for the actual percent of change. Now, use your common sense. Yes, in this case, I know I did it in the right order, so I can trust that negative means decrease. But let's use our common sense. Our original number is 25. Our new number was 10. It got smaller, so clearly this question, the answer is going to be decrease of, and then we're going to state the answer. And if we just have the round 0.6, we just turn that into a percentage. And to remind you, to turn a decimal into a percentage, you move that decimal place 2 spaces to the right. So that becomes 60. So that means 60%. And because we said decrease, it's a decrease. So we have a decrease of 60%. That's our final answer to number 1. Now we're going to do the same thing for number 2. Identify the new and the original. Oop, did that backwards. Nope, I did right. New is in red, original is in green. Plugs those in. That means on top we have 95 minus 90. And we're going to take that answer, we're going to divide it by 90. Well, 95 minus 90, well that's just 5. So we have 5 divided by 90. Find out what that is as a decimal, convert it to a percentage, and say increase or decrease, and you're all done. We get 0.555 repeating. The 5's repeat, but regardless, show enough to where you can be able to find your answer. So to convert that to a decimal, move it over twice, and so that means we end up with 5.55%. Well, it said round to the nearest whole number. So if you had 5.55 rounding to the nearest whole number, the number immediately after the decimal tells you how to round. That's a 5, and that means round up. So that means this 5 is going to become a 6. So we're dealing with 6%. And in this problem, our original was 90, our new was 95, so it got bigger. Therefore, we're going to say an increase of 6%. That would be our final answer to number 2. Okay, so now I've got 2 examples for you to try. You're going to hit pause and you're going to try both of these. They're going to be just like your last example, so just make sure you're using the same formula, that basic understanding of how to find percent of change. Alright, so press pause. They both set up exactly the same. New minus original divided by original, so make sure you just plug each of those numbers in where they go, and now just find out what they equal. Now find the decimal answers for each of those, and then you'll turn that decimal into a percentage. Okay, once you have your decimals, 12 divided by 48 is 0.25, 3 divided by 25 is 0.12. You've got your decimals, now just convert those to a percentage. Remember, anytime you convert from a decimal to percentage, it's always move the decimal place 2 spaces to the right. So, that first one becomes 25%, and the second one becomes, our second example becomes 12%. Now, just use your common sense to determine whether it is an increase or a decrease. Now, number 3, the original was 48, the new was 60, so it got bigger. So that's going to be an increase of 25%. Now, number 4, it went from 25 to 28, it also got bigger. So coincidentally, number 4 is also an increase. Now, remember, use your common sense. If you had accidentally subtracted these backwards and you'd gotten a negative answer here, or on this one, that's okay. You would just use your common sense to fully help you decide was an increase or a decrease. It's not the end of the world if you subtract these backwards, but if you do, you will end up with the opposite sign of what you should have. But if you know you do it in the correct order, you can trust the sign. Okay, so now we're going to move on to a little more of the problem solving. We're going to talk about taxes and tips. They mathematically are the same, and we're going to talk about discounts. So whether it's a tax or a tip, mathematically is the same. They both increase your price by some percentage amount. So let's say, for example, you were buying concert tickets, and those concert tickets had a price tag of $48. You're buying them in a place where you have sales tax of 7%. Your job is find the total price, and we're talking money, so you're going to round it to the nearest cent. In other words, mathematically, rounding to the nearest hundredth, meaning 2 numbers after the decimal. So make sure you increase your cost. So the slower, longer, but more intuitive way of understanding how to do this question is find what is 7% of 48. Meaning 0.07 times 48. Find out what that equals. Find that number and add it to 48. Yeah, that is one of the most ways to think of it. Or you can think of maybe the shortcut that we talked about in Chapter 6. We found a slightly fast way of solving these questions. And that shortcut is as follows. You're guaranteed already going to be paying 100% of $48. You're at least paying $48. But not only are you paying 100% of $48, meaning $48, you're also paying an extra 7%. So grand total, you're going to be paying 107%. So that's going to be the percentage value we're going to use for this question. So we just need to find out what is 107% of 48, because that'll include 48 plus our tax. And you know it's more than 100% because tax increases your price, so you should have a percentage that's going to increase your price, meaning a percentage more than 100. So in order to do this, convert that percentage to a decimal. 107% converts to 1.07. Now, you're going to multiply that by your original price, by your price tag, by $48. The answer to this question will be your final answer. Just make sure you round it to the nearest penny. We end up with 51.36. So that tells you your total cost, including tax, is $51.36. There was no rounding necessary for this question. That's your total cost, including tax. Before I move on, I want to point out that if this question had been slightly different, let's say the tax rate had been 7.5%. If the tax rate had been 7.5%, then we would have had 107.5%. And so meaning when we actually did our calculation, we would have 1.075. So you would have done everything exactly the same, but if your percentage has a decimal already, that's okay. So it would just look like this. Then obviously we would get a slightly bigger number here. We got a different number, so we would have a slightly different answer. But I wanted you to know what would happen if your percentage was a decimal. All right, now let's you do an example. Alright, I want you to try this example. Now notice, I'm still doing you a favor though. We're not necessarily focusing on word problems right now. I'm giving you the bare information that could be used in a word problem. For example, let's say you're buying a shirt and that shirt has a price tag of $28.95. You're in an area that has a 6% tax rate. Find your total cost, and we're talking money, so round to the nearest penny. Alright, press pause. You try. Okay, taxes increase your cost, so it's going to be more than 100%, so it's going to be 106%. Is the grand total of what you're going to be paying. Well, 106% is a decimal for you to use is 1.06. So we're going to take 1.06, we're going to multiply it by our original price, by 28.95. Find out what that equals, and that's going to be your final answer. You end up with 30.687. We're talking money though, so we need only two numbers after the decimal. That doesn't mean you get to ignore the 7. That means you need to look at the 7 because the 8 is what we need to worry about rounding up or down, and the 7 tells you how to round. So since the 7 is 5 or larger, that means we're going to round up. So this 8 is going to become a 9. So our final answer is going to be $30.69 is what we're going to end up with. So the total cost of our shirt, including tax, is $30.69. Okay, the other situation we said we would talk about was how to handle discounts. And remember, discounts decrease your price. So when we do each of these questions, you should have an answer that's less than the original. So let's say you're buying a backpack. The backpack has a price tag of $56.25. But it's on sale, you're at a store, you have a coupon, something like that, and you find out that it has a discount percentage of 20%, meaning they're going to take 20% off. Yes, the longer, more intuitive way is find what 20% of this is, subtract it from 56.25, and then yeah, that'll be your answer. Or we can work a little bit faster. Since you're going to be paying less than 100% of all of 56.25, you're not paying all of 56.25, you're going to pay a little bit less than that. You're going to pay 100% minus the 20% discount. So you are only actually, your sales percentage, meaning the percentage you're actually paying, is only 80%. So that's going to be the percentage we're going to use. This is the shortcut method. This is the faster way. So we're going to take that 80%, we're going to multiply by the 56.25, and we'll have our answer. You can write that as 0.8 or 0.80, doesn't matter. Find out what this equals, and then that'll be your answer. Just make sure you round to the nearest penny. That comes out to 45 even, so that means our final answer is $45. That's going to be our total cost, or not a total cost, at least be our price before tax for this backpack with this discount. So we took off 20%, so that means 100% minus 20%, it means we're only paying 80%, so that's the magic number we're going to use. We're looking for what is 80% of 56.25, so it should be an answer that's smaller. Before we move on, I want to point out there are questions where you're going to have in the real world even you're going to be doing both. You may have items that have a discount and they have everywhere you have sales tax pretty much. So you will also have questions. We're not going to include them in this video, but you'll do each of these steps separately. You'll do this step to find the price after the discount, and then after that you'll then do this step to find the price after the tax. So if you get a combination, you can do both. Alright, so you're going to try this example, we're going to check yourself, and you're going to be all done. So, we're buying a sleeping bag for $125, we're taking off 25%. What is our total price? Remember, round to the nearest penny. Hit pause and try this one. Press pause. If it's 25% off, you'll only be paying 75%. So what is 75% of 125? So our final answer is $93.75. That is the price of this sleeping bag after we take off our discount. In other words, this is the sales price after the discount. So if we were doing a more realistic question, or if you were just having a two-part question, I said, now what's the total cost after tax? You would use this amount and pay tax only on this amount, only $93.75. You would not be paying taxes on $125. Alright guys, make sure your notes are complete, and remember, if you need any more help or details for some of these skills that if you need more explanation where the shortcut came from, please check out the Chapter 6 videos on percentages and percent skills. I will include links to those in the description of this video. Take care.